Hello everyone. Today we are doing the part 2 of stoichiometry problems, limiting reactant. Limiting reactant is a reactant that gets consumed first in the reaction. Now in a reaction, there'll be two reactants. One will be a limiting reactant and one will be an excess reactant. So let's consider a reaction. To simplify the concept, we are considering a very simple reaction. Carbon plus oxygen gives CO2. So first we have 1 mole of carbon reacts with 1 mole of oxygen to give 1 mole of carbon dioxide. That means 12 grams of carbon reacts with 32 grams of oxygen to give 44 grams of carbon dioxide. This we have studied. Now, this I take this as the reference line. Now, in the question, limiting reactant question, they're going to ask that if we have 6 grams of carbon and let's assume we have 8 grams of oxygen, you have to first find which one is the limiting reactant and which one is the excess reactant. So let's first find which one is the limiting reactant and which one is an excess reactant. So let's consider case number 1. If we take 6 grams of carbon, we can't take 8 grams of oxygen here. Why? Because this is given in the question, but we have to go by the mole ratio. So let's assume this is X. To find X, we use the unitary method, and X comes out to be 6 into 32 divided by 12, and this is equal to 16 grams. So this is 16 grams. Now, if you can check in the question, they have given 8 grams of oxygen, but we are taking 16 grams of oxygen. So this case is wrong, and we have to go to case number 2. In case number 2, we start with 8 grams of oxygen. Now, to find how many grams of carbon do we require, let's assume this is Y. Using the same reference line, we will find the value of Y. The value of Y can be calculated as Y is equal to 8 multiplied by 12 divided by 32. This gives you 3 grams. That means 3 grams of carbon is required. And in the question, we have 6 grams of carbon. So you can easily say that only 3 grams is required. That means extra 3 grams of carbon is left. This shows that carbon is in excess. This is in excess. If this is in excess, that means oxygen is the limiting reactant. Limiting reactant. Now, in the second B part, if I ask, find the mass of carbon dioxide produced. Find the mass of CO2 produced. Now, using the case 2, we will find the value of mass of carbon dioxide produced. Let's assume this is Z. Using the same reference line to find Z, we use the unitary method. Z is equal to 44 multiplied by 8 divided by 32. And this gives you around 11 grams. This is 11 grams. Let's do a question, an exam style question here. We have 9.2 grams of sodium, which is reacted with 8 grams of sulfur to produce sodium sulfide. Find which one is the limiting reactant and which one is the excess reactant. So first you have to write a complete balanced equation. Sodium plus sulfur gives sodium sulfide. So if to balance it, you put 2 over. We have 2 moles of sodium, 1 mole of sulfur, and 1 mole of sodium sulfide. 2 moles of sodium means 2 into 23 grams. 1 mole of sulfur is 32 grams. And this is 46 plus 32 grams. So case number 1, if we take 9.2 grams of sodium, now we can't take 8 grams here because we have to go with the mole ratio. Let's assume this is X. We have to find X. Again, we use the unitary method to find X. X is equal to 9.2 times 32 divided by 2 into 23. This gives you around 6.4 grams. 6.4 grams. If this is 6.4 grams, you can check whether this satisfies the question limitation. This is 6.4 gram, and in the question they have given 8 grams. That means we can easily use 6.4 grams, which shows that sulfur, there is excess sulfur. So sulfur is acting as an excess reactant, whereas sodium is acting as a limiting reactant. So hence prove that sodium is the limiting reactant and sulfur is the excess reactant. Again, let's say we have a question, what mass of calcium hydroxide is formed when 10 grams of calcium oxide reacts with 10 grams of water? So again, we will write a fresh reaction. We have 1 mole of calcium oxide reacting with 1 mole of water to give 1 mole of calcium hydroxide. We will write the masses. Here we have 40 plus 16 grams. This is 18 grams. This is 40 plus 32 plus 2 grams. Now case 1, we will take the calcium oxide mass, which is 10 grams. Again, using the mole ratio, we will find the mass of water that is required to react. We will use unitary method, and X comes out to be 10 into 18 divided by 56, which is equal to 3.2 grams. Now in the question, you can check, we have 10 grams of water which satisfies the condition. So case 1 is correct. We can further find the value of calcium hydroxide. But first, we know that water is acting as the excess reactant and calcium oxide is acting as a limiting reactant. To find the value of calcium hydroxide produced, let's assume this is Z. To find Z, we can use the reference line. You can take unitary method here. Z is equal to 3.2 multiplied by 74 divided by 18 gives you 13.15 grams. So the amount of calcium hydroxide produces 13.15 grams. Now, I hope you understood the limiting reactant concept. So for you, this is the question given. You can try and write your answers in the chat box. Thank you.